The ozone cycle. Located as a layer within the stratosphere, just above the troposphere, and extending out to about 20 to 30 kilometers above sea level, a layer of ozone is located. There, it intercepts and blocks very energetic, harmful ultraviolet radiations, UVC and most of UVB, from reaching the Earth, limiting their destructiveness. In absorbing these radiations, the ozone molecules decompose and go through a cycle in which they are reformed. This cycle is illustrated as follows. So what we're having on the left-hand side are chemical equations to show you how this cycle operates. And on the right-hand side, we're having these space-filling models. So you can follow either of them. So initially, what it is saying here is that oxygen molecule absorbs UV and gets decomposed as follows. So of course, you know, UV is very energetic. So it has enough energy to decompose oxygen molecule. So when that happens, it forms two oxygen atoms. The atoms in these forms are said to be very active. We call these activated atoms because they're capable of reacting with other species with relative ease. So what happens next is this. One of these activated oxygen atoms will encounter an oxygen molecule, and that forms ozone. That reaction there creates ozone. So this is how ozone is initially created, okay? Now see, these other two reactions here will comprise the ozone cycle. So what is going to happen now is this. Once the ozone molecules are formed, they will then intercept UV that's coming into the stratosphere, and in the process, they get decomposed into oxygen molecules and oxygen atoms. So a single ozone molecule is decomposed as follows. It gets broken down into an oxygen molecule and another activated oxygen atom there. But what you should also note is this. Because it is absorbing UV, that part of the stratosphere experiences a rise in temperature. Recall that at the tip of the troposphere, the temperature there is negative 67 degrees Celsius. That is at the beginning of the stratosphere. But then the final temperature that is attained by the stratosphere is negative 2.5 degrees Celsius, a jump of about 45.5 degrees Celsius, okay? So two things to note. As the ozone molecules absorb UV, they get decomposed into these products here, and energy is retained in that layer of the stratosphere. Finally, once these guys are formed here, they will quickly react with each other to reform the ozone molecule here. So these two reactions depict here for us how the ozone layer is being maintained. Now we look at CFCs and ozone layer depletion. I'll give you some time to read this here. I'll just make some brief comments about that. It's clearly written there. It's all factual. So this paragraph is giving us an historical background of the invention of the first CFC, chlorofluorocarbon, freon, and the reason for its invention. It was to replace the toxic and flammable compounds that were used as refrigerants and insulators in foam mattresses. It also tells us about its widespread usage in the 1970s, with millions of tons of it being produced because of its non-toxicity and usefulness. However, people did not realize that all of the freon that subsequently escaped the discarded refrigerators and mattresses ended up in the stratosphere, causing destruction to the ozone layer there. This paragraph is telling us that the first Scientists to speculate and investigate this phenomenon were University of California chemists Sherwin Rowland and Mario Molina. Their assertion that large amount of freon ended up in the stratosphere and was causing effects on the ozone layer there was validated in 1985 when three British scientists discovered a hole in the ozone layer in the Antarctic region. In 1995, one of these three British scientists, Paul Crusten, along with Sherwood Rowland and Mario Molina, were awarded the Nobel Prize for their outstanding work. And this brings us to the ozone layer depletion. First of all, this is what happens. When a molecule of CFC, such as freon, encounters ultraviolet radiation, it decomposes with one of its chlorine atom breaking away. Okay? Now, of course, CFCs, we mentioned in that paragraph, are hydrocarbons in which the hydrogen atoms are replaced by both either chlorine or fluorine. So in this case, this was methane molecule as carbon here, and you see you have two fluorine atoms here and two chlorine atoms here. So all four of its hydrogen atoms are replaced by fluorine and chlorine atoms. So let's go back to this. The space filling model here is showing us what happens when freon molecule encounters UV. When that happens, you see a chlorine atom is produced here. And again, this chlorine atom is said to be activated. It's an active chlorine atom that's capable of undergoing rapid chemical changes if it encounters any species that it can react with. So see what happens there? This free activated chlorine atom then reacts with an ozone molecule here and produces an oxygen molecule and this chloro-oxygen species here. This chloro-oxygen radical also is an active species, and it is also capable of reacting with other species too, very willingly. So what does it do? It now encounters another oxygen atom, and in so doing it produces oxygen molecule, and that gets freed. So what are net changes that are happening here? Let's look at these two processes here. The net change that has happened here is that we no longer have an ozone molecule here. See? It gets destroyed. And see what happens? This guy that initially caused its destruction gets freed again. So the ozone molecule actually is being changed into oxygen molecules and oxygen atoms here. Right? But this guy is said can now go on and do the same thing again. Can go on, react with another ozone molecule here, and produce a molecule of oxygen and another chloro-oxygen species here. And then this can react with an oxygen atom there to produce oxygen molecule. It is said that this guy can destroy as much as 100,000 ozone molecule. All right? So this brings us to the final thing here that we got to talk about, was called a Montreal Protocol. All right, you can read that. It's all written there. So what this paragraph is telling us here, in 16th of September 1987, that a Montreal Protocol was signed, and this represents one of the most concerted and unprecedented efforts by countries of the world to stop the production of ozone-depleting substances and to phase out its use in a timely manner. These ozone-depleting substances were to be replaced by hydrofluorocarbons, HFC. So these were the decisions that were made. The more developed countries of the world were mandated to make the switch with urgency, while the developing countries were given more time because of the associated costs of this process. You see, for CFCs to work, all existing structure had to be changed since they couldn't function with CFC. Those refrigerants and stuff like that that used to work with Freon or CFCs, they couldn't work with HFC, and to replace those structures was very costly. So what did they do? They established a replenishable multilateral fund consisting of billions of dollars to facilitate the poor countries in this endeavor. So they had a fund there. I think every 3 years after they have assessed the improvement and stuff like that that the poor countries are making, they will replenish some amount of money into that fund there to help all these poor nations to make the switch gradually from CFCs to HFCs. All right?